Hi everyone. Today I'm going to talk very briefly about a certain thing that is going on in the AI industry or in terms of the discussions that are going on in this industry at present with respect to all this vibe coding and coding assistants that are available. So many people are claiming they're saying that I mean, uh, like now it doesn't matter whether you are like highly qualified in terms of getting a formal education in either AI, computer science, or statistics. All you need to know is just how to use these coding tools, and that'll be it, and you'll just be on your way. Now, I would like to tell everyone that based on my own experience that yes, coding tools have helped us, they are helping us tremendously to code faster, but those tools are of no use if the person who is using that tool doesn't know the basic concepts of AI, of statistics, mathematics, which are required here, right? So it's very important that these concepts are very clearly understood. Only then will the person be able to make the most out of these tools. Otherwise, what will happen is that they'll develop a working solution, but that working solution will not go anywhere, meaning that they will build something in an automated mode by using either Cursor or Windsurf, Cloud Code, these kinds of coding tools or something else, and that will work. That will definitely work on a toy implementation, but that will almost certainly fail when you get to the actual battle testing in a production ground. Like you're basically trying to deploy that thing into production and then see how it actually responds to real time traffic, real user traffic, or real world settings, right? So that's what I would say, that you guys need to understand this very well, and just remember that both theoretical knowledge and practical knowledge are equally important. They are as equally important as they used to be in the past. The only difference now is that the implementation part of it has gotten a lot more easier, so that you can spend a lot more time on the theoretical side of things. And this is actually a great thing, because earlier it was not the case. Earlier people, especially folks who joined industry early on, maybe right after graduating in the bachelor's or right after masters, they joined a job and they had to learn things um, on the job itself, like practically, right? And from my own experience, I can say that I joined the typical corporate industry much later in my career, and I did that after completing my PhD and my postdoc. Until that time, I had already gained a lot of substantial theoretical knowledge of statistics, AI, mathematics, and computer science to a large extent. And after that, I started implementing them in my tenures in corporate across these different companies. And I could see that how that differs as compared to if I would have just right away entered into the corporate sphere immediately after graduating, because that way I my mind wouldn't have opened that much as it did, like because I did my PhD and my postdoc. Now that doesn't mean that I'm saying that everybody would have to do a PhD and a postdoc. That is a career path that definitely accelerates this, but it's not like indispensable. What I'm trying to get at here is that like the theoretical knowledge and the practical implementation of it, the practice of it in parallel, are both important. And you guys who are aspiring AI scientists, AI developers, who are right now either freshers or mid-career professionals jumping onto this AI scene as it is evolving, you need to understand that you can spend like every part of your day, some part allocated to theoretical understanding of basic concepts, in that let's say powers neural networks, like linear algebra and calculus. Linear algebra, which is used all the time in the form of matrix multiplications and additions, projections, which is what you actually see happening in parallel in all these different kinds of neural network architectures, like be it typical multi-layer perceptrons or feed-forward neural networks, be it convolutional neural networks, be it more advanced transformer-based neural networks, which are based on self-attention, right? So in all of them, what is basically happening in the forward pass is basically a, a series of matrix multiplications and vector additions, which is nothing but linear algebra. And at the same time, you also have the backward pass where you're basically taking the derivative of your loss function and basically chaining that derivative backward till the start of the network, right? And that backward propagation involves calculus because you're basically computing first order derivatives, and not just that, you're also using the chain rule of differentiation as we had learned in high school. So both linear algebra and calculus are massively used in these two critical parts of training any neural network architecture, right? So you can understand, if somebody doesn't understand these concepts very well, that person won't be able to understand any new neural network architecture, won't be able to build a solid neural network architecture and train it efficiently so that it serves the practical purpose in a certain business context in real world. So this thing is very important, and at the same time the implementation side is also important. So you need to learn about linear algebra, calculus, especially matrix multiplications, vector additions, projections, and derivatives. And at the same time, you also need to practice that by actually building an actual neural network and sort of trying to train it on some real life data, that is some freely available data out on the internet. There are lots of them actually, and you can basically train that same neural network using GPUs, and basically see how actually this matrix multiplication works, and this chain rule of derivatives work in practice with aided by these GPUs, which are nothing but parallel computing hardware, right? That has been built for parallel computing. So things like this, right? So um, it is, I think, very critical for all of you to develop this kind of learning approach towards being a highly effective data scientist, AI scientist, and AI engineer in future. Thank you.